Hello students, this is very easy question that we have to prove the external direct product of the group G1 and G2 is isomorphic to external direct product G2 and G1. So G1 external direct product G2 is isomorphic to G2 external direct product G1. So how to show this? How to prove this? Where G1 and G2 are two groups. Okay. Do you have any idea? So if we can make a 1-1 onto homomorphism, that means if we can make a isomorphism from this to this, then these two groups are isomorphic. So now we are going to make an isomorphism. So let G1 and G2 are two group. Okay. Should it be finite? External direct product, for defining external direct product, is it necessary to being finite group? No. Okay. So let G1, G2 are two groups. Okay. And G1 external direct product G2, it is the group defined as, okay, this group is defined as G1, G2 such that G1 from the group capital G1 and G2 is the group from the group capital G2. Okay. And G2 external direct product G1, how it is defined? So this is also defined like this. The first element will come from G2 and second will come from G1, and this is the group. G2 belongs to capital G2 and G1 belongs to capital G1. Okay. So these two are external direct product group. Okay, these two are groups. So we have to make a we have to show these two are isomorphic. Then we have to make a bisection from this group to this group or this group to this group. Okay, one group to another. Make a bisection, which is also homomorphism. Okay, make an isomorphism first. So define a function. So let us define. Let's define a map. Let's define a map. That means define a function. So phi of phi from G1 external direct product G2 to G2 external direct product G1. Okay, define a function such that how it is defined, such that phi of G1 comma G2 is equal to G2 comma G1. Okay. So first we will show it is well defined. Then we will show it is 1-1 onto an homomorphism. It will be work in 4 steps. Okay. Step 1. You have to show well defined. Well defined. Take any two element in the domain. Let G1 comma G2, okay, one element, and another element is G1 dash comma G2 comma dash. These two elements are in. Okay, let these two elements belongs to G1 in the domain G1 external array product G2. Okay. In the domain we are taking two elements. And suppose that these two elements are equal. G1 is equal such that G1 comma G2 is equal G1 dash comma G2 dash. Now what happens? It will give G1 is equal to G1 dash and G2 is equal to G2 dash. Okay. Now what happens? If G1 is equal to G1 dash, G2 is equal to G2 dash, you can write like that. G2 G1. Okay. This is equal to, in the place of G2 you can write G2 dash because they are equal. In the place of G1 you can write G1 dash because they are equal. This will imply this, and this will imply it is the image of, that means phi of, it is phi of G1 G2. This will imply phi of G1 G2. It is the phi of G1 G2 and it is the phi of G1 dash G2 dash. Okay. According to the definition of this function, if the elements are equal in the domain, then their images are equal. Same element have same image. Okay. Two elements are equal, then their images are equal. That means one element have only one image. Okay. Every element of this group has unique image. So well defined. Okay. Hence well defined. Now the second part is, that is onto. Okay. Step 2. What we will show? We will show that phi is well defined. Next we will show phi is function. Phi is 1 1. Phi is 1 1. What we will do? Okay. Take any two images. To do 1 1, we have to we can take any two images in the codomain, and then we can show that the three images are equal. This is one process. And another process is also we can use that if we take any two distinct images in the distinct, if we take any distinct, okay, if we take any two different elements in the domain, then their images are also different. That is also okay. So let G1 G2, this is one element and this element is different, that means distinct from G1 dash G2 dash. Okay, these two elements are not equal, that means distinct, these two elements are distinct in domain. Okay, G1 external direct product G2. So this means if these two are not equal, that means either G1 is not equal to G1 dash or G2 is not equal to G2 dash. If G1 is not equal to G1 dash, G2 is not equal to G2 dash. In both these cases, we can write G1. We are going to show what? Images are not equal. G2, G1 not equal to G2, G1. If G2 not is equal to G2 dash, we can write not equal. So write here an element in place of G2, write an element which is not equal to G2. Not equal to G2, that is G2 dash. Here either this not equal or this not equal or this not equal and this not equal, both. Okay, both the things happen. These two are not equal, that means this is not equal to this is not equal to this, and this is not equal to this, and this is not equal to this. Not equal, that means either this is not equal to this, either this is not equal to this. And another one condition is also these two things happens simultaneously. Okay, this is not equal to this and this is not equal to this. In that case, it is also happening. And either this not equal to this or this not equal to, or another condition is G1 not is equal to G1 dash and G2 is not equal to G2 dash. This can happen, or these two simultaneously can happen. In both these cases, in all these cases, we can write G2 not is equal to G1, G2 comma G1 not equal G2 dash comma G1 dash. Okay. Okay. G2 not is equal to G2 dash, so not equal. G1 is not equal to G1 dash, so this is not equal. From this we can write this. Okay. Okay. This will imply phi of this is equal to phi of G1 comma G2 not equal, and this is we can write phi of G1 dash comma G2 dash. Okay, this is G2 dash. Phi of this not is equal to phi of this. These two are distinct element in domain, and these two, the images are distinct. If the element are distinct, their images are also distinct. Hence it is 1 1. You can try with take phi of this is equal to okay, this, then you will get this is equal to this. This is also very simple process. If you not use this, then use this. We can or if you have doubt with this, now take the or part. So we can prove 1 1 like this process also. So or process. If you don't write here, write this. Okay. Let phi of G1 comma G2 is equal to phi of G1 dash comma G2 dash. So this will imply this is equal to G2 G1 and it is equal to G2 dash comma G1 dash, and it will imply G2 is equal to G2 dash, G1 is equal to G1 dash. Okay. This really implies G2 G1 in place of G2, right? In place of G2, write G2 dash. G2 dash is equal, in place of G1, write G1 dash. And this is equal to G2, G1. That means phi of G1 comma G2. G2 dash, G1 dash. This is means phi of G1 dash comma G2 dash. Okay. Okay. So this. Okay. What do we have? Okay. So here it is done. Okay. So this not is equal, this equal to this, and this equal to this. Now we can write this will implies G1 comma G2 is equal. In place of G1 you can write, in place of G1 you can write G1 dash. Both are equal. So write here G1 dash, comma, in place of G2 you write G2 dash. So images are equal, then the three images are equal. Okay, these two are element, this and this, these two are element in the domain, and their images are equal. That means the elements in the domain are equal. So this is equal to this. Okay, so this part, do this part, hence it is 1 1, hence phi is 1 to 1 mapping, 1 1 mapping, right? 1 1 mapping. Okay, so now we will do it, we will show that it is onto state 3. Phi is onto state 3. Phi is onto how to show onto? Okay, take an element in the codomain. What is codomain? G2 extended G1. So phi is from G1 extended direct product G2 to G2 extended direct product G1. So this is the codomain. Take an element in the codomain. So let y, okay, y1, y2, let y1 comma y2, you can take AB, anything you can take. Okay, so let A comma B, this is an element. हाँ, इससे फर्क पड़ता है, मतलब ये लेने से भी कोई भी एलिमेंट, you can take any element, but the element you take in is like that it will give a meaning. Okay, meaningful element. So y1 y2, that is very good. So let y1 comma y2, this is an element, this is belongs to G2 external direct product G1. Okay, this will implies, okay, G, this is y2 y1, take y2 comma y1. Okay, because it is an element in G2 external product G1. So y2 is from, so y2 belongs to G2 comma y1 belongs to G1, and y1 belongs to G1. So this will implies if y1 belongs to G1, y2 belongs to G2, y1 comma y2, this element will belongs to what? First element will come from the first group G1, second element comes from the second group G2. So y1 comma y2 belongs to G1 extended direct product G2. Okay, is it visible? Okay, so if you take an element in the codomain, so you have obtained an element in the domain such that, and such that phi of y1 comma y2 is equal to y2 comma y1 such that phi of y1 comma y2 is equal to y2 comma y1. If you take an element in a codomain, so there is a pre-image. The pre-image is this. Phi of this means this is equal to the pre-image of this element is this. So every element have a pre-image. So phi is onto, right? Hence phi is onto. Is onto. Now the last part is we have to show that phi is homomorphism. It is very easiest step. Okay. Step 4. We have to show phi is homomorphism. Phi is homomorphism. How to show phi is homomorphism? So phi is homomorphism is phi satisfy the group operation. What is the group operation? The group operation is this. Take okay, phi of A star B is equal phi of A dot phi of B. Okay. Then phi is a homomorphism. Star is the operation of G1 first group and dot is the operation of the second group. So phi is a homomorphism. Let A is equal, A is an element G1 comma G2 and B is an element G1 dash comma G2 dash. Okay, these two are elements G, A and B. So phi of A, B. Okay, I don't know what is the operation with of operation of. Okay, operation of what? So operation of G1 extended direct product G2. So I don't know what is G1 G2. Operation is not defined. So any operation you can give here star also. You can take here star. Okay. So this is equal to phi of A means G1 G2 and so G1 dash G2 dash. So you can if you don't write the operation between, it will work, nothing to it. Okay. Phi of this is equal to phi of operation between these two. Okay, component wise multiplication G1 G1 dash G2 G2 dash. So because these two are ordered pair, so phi of this is equal to, you can write G2 G2 dash comma G1 G1 dash. Okay, now you can write this is equal to G2 G1 G2 comma G1 into G2 dash comma G1 dash. So then G2 G2 dash G1 G1 dash. Okay. So this is equal to, you can write. So this is equal to phi of G1 comma G2 and this is equal to phi of G1 dash comma G2 dash. So this is equal to phi of what is G1 comma G2 is equal to A and this is the phi of G1 dash comma G2 dash, this is equal to B. So phi of AB is equal to phi of A, phi of B. So hence it is a homomorphism, phi is a homomorphism. Hence you write phi is isomorphism and isomorphism SN, okay, isomorphism from G1 external direct product G2 to G2 external direct product G1 isomorphic of G1 external by G2 to G2 external by G1. Hence, right here, hence G1 external direct product G2 is isomorphic to G2 external direct product G1. Is it visible? And the proof is also complete. We are going to show that this is isomorphic, hands down.